Okay, welcome everyone. So we're up to proposition 27. So proposition 27 says, if a straight line falling on two straight lines makes the alternate angles, and I'll define that, equal to one another, the straight lines will be parallel. All right. So here's the diagram. So here's my two straight lines. Just give me 1 second, I'll be back. You could shut up the wasp as well, that would be great.
That's right. Oh, sorry.
Okay, sorry about that. Okay, so a straight line falling on two straight lines. So there's our two straight lines, and here's the line falling on them. So let's call it AB and CD. And this is EF. A straight line falling on two straight lines makes the alternate angles equal to one another. All right, so proof. Suppose AEF is equal to EFD. Right, so those are the alternate angles. So we claim AB is parallel to CD. This is not a concept we've talked about a lot. I'll just define it. So two lines are said to be parallel if they don't meet. That's the definition at the beginning of the book. All right. Okay, so to prove that, it's a proof by contradiction. So suppose otherwise. Then ABCD, when extended, well, they have to meet, either meet in the direction of BD or towards AC. Actually, I'm not sure on what basis this is justified. That's sort of saying that this straight line EF divides the plane into two pieces. I didn't think carefully about how to really justify this sentence. Maybe we can discuss it later, but let's just run with it. So suppose the proof's the same in either case, obviously. So let's suppose without loss of generality that they meet in the direction of BD. So suppose without loss of generality, they meet on the side of BD at, say, G. Okay, so there's a G here. These are straight lines, these dotted lines. So we keep going, potentially very far, but they do meet at G. So this line here and this line here are straight. Well, then we can look at this triangle. Doesn't look much like a triangle, but it is, right? EGF. So consider the triangle EGF. the external angle AEF is by hypothesis equal to the internal angle EFG. And that's a contradiction. I think it's proposition 16. All right, so proposition 16 said the exterior angle has to be greater than the interior, and both the interior and opposite angles of a triangle. So this contradiction shows that our hypothesis that they meet on the side of BD is incorrect. Therefore, they don't meet, and similarly on the side of AC. So we're done. That we've proven that those two lines must in fact be parallel. All right, over to you, Kenneth.
Cool.
You can attach a speaker, or I can just walk over there for you. Maybe
Cool, I'll
attach
let
a
you walk.
speaker. Yeah, you can do it. They don't listen to you.
All right. So I think we're pointed at the right board. All right. So proposition 28, I think, is the converse to this one, right? Let me just pull it up. Proposition 28. Man. Ooh, again. All right. Hang on. You know what I need to do? I need to get rid of my jacket. It's drawing on the screen. All right. So proposition 28 is, I think, is a converse to the proposition that Dan just presented. So it's proposition 28. So there are actually two parts to this. I'll kind of write them up in separately. I think in Euclid they have it together, but I'll separate them for clarity. So if a straight line falling across two straight lines so there are two conditions, right? One has an external angle equal to the opposite internal angle. So if you guys would have used the same terminology as I did when I learned this in, primary school, these will be corresponding angles, right, on the same side of two lines, and two internal angles on the same side equal to two right angles. All right, so these are two conditions. If either of these are true, then the two straight lines are parallel. Straight lines are parallel. So I think probably draw the diagram on the next board, just because there's no room for the proof. So I'm going to walk over to board number 3. Hopefully this time it works right. So I do this, and let's check the cam. All right, so that's good. All right, so I'll draw a diagram that represents the two conditions. So we're gonna have two, trying to fit the proof on this board. So I'll try to make the diagrams up here. So you got two lines like this. So, and a line falling across them. I'll label these AB for the first line and CD for the second line, and the line falling across EF. So condition one says that the external angle, so this is an external angle, and this is the internal angle on the same side, right? These have to be equal. So that's one, so I'll prove one first. So I guess the statement is that if E, oh, I need to label the intersection points G and H. Right, so if EGH is equal to angle GHD, then AB is parallel to CD. Proof. So Dan, before I give the proof, what was postulate 5 again? What was it? Just that parallel lines don't meet? Dan? Oh, maybe he's not here. All right. So
I am here. Sorry.
Oh, you are?
It's postulate 5.
Yeah.
Are we using that already?
No. I mean, I remember you mentioned it earlier. I don't have this being used in my notes. I was just wondering what it says. Something about parallel lines, but I forgot exactly what the statement was.
Well, I'm going to give the statement after this proposition, so don't steal my thunder.
Cool. Sounds good. All right. So I'm not using it. I thought that maybe you used it. Anyway, cool. All right. So leave that on until after. I'll hopefully finish in time to give you some time to do postulate 5. So the angles HGH. So where was I? Okay. So the angles AGH and EGB. Now I realize I made a mistake. This should be EGB in the statement. EGH doesn't make any sense. It's just a line. EGB. Okay, so EGB equal by proposition 15. Right, this is the one that says that opposite angles cross when you have two intersecting lines are equal. Right, so since the angles, so let me just mark this, right? So this is what we just concluded. Since the angles EGB and GHD are equal, by hypothesis, right, the pair of alternating angles or alternate angles, that's not how you spell alternate, angles, so the pair of alternate angles are AGH and the other one GHD are equal. So we have the claim follows from the previous proposition. Okay, so yeah, so basically you've got these corresponding angles being equal. You can just make this opposite angle equal, and you observe that the alternate angles now equal, so the lines are parallel. And so I'll go to the next board to finish it off. There's another case 2, where the internal angles add up to 2 right angles. The proof is very similar, slightly different, because we have the sum of 2 angles adding up to 90 degrees or 180 degrees rather than angles being equal. So let me redraw the diagram quickly. All right, so these A, B, C, D, E, F, G, and H. Okay, so in this case, the hypothesis is that this angle and this angle, the two marked angles, add up to two right angles, right? So if I guess here is AG. Did I just draw H at the same place as F? That's crazy. H is here. All right, so yeah, so here, if, what is it, AGH and GHC are two right angles, or sum to two right angles, then AB and CD are parallel. Is parallel. And CD are parallel. Okay, so the proof, right? So the proof here is using a slightly different proposition than the one before, 1.13, that says that on a straight line, two adjacent angles on a straight line add up to two right angles, and then we're going to subtract AGH from the sum of the straight line, I guess here, right, and the sum of AGH and GHC, and to show that the two, the X and the red marked angles are equal, and there you go. Right, so we're going to use by, ooh, that's red, by proposition 13, the two angles, which two? So it's AGH, and the red one, BGH, are two right angles. Right, so now subtracting AGH from, I guess, from AGH and BGH, and I guess I'm using and like three times, but hopefully you get what I mean. AGH and GHC. So these are both, you know, sum to two right angles, right? Gives the remainder GBGH equals to GHC, right? So BGH is the red one, GHC is a cross, right? So hence the claim follows again from proposition 27. Right, so I guess the thing that I didn't explicitly say was that these angles are alternate angles on AB and CD, right? So you've got two alternate angles, they're equal, so proposition 27 says that they must be parallel. Cool, I think that's it.
Yeah, great. I guess we've only got 5 minutes left. We could either talk about the parallel postulate now or save it for next time. I think we don't have time to do the next proposition. Maybe it's better to just leave it there and introduce the parallel postulate at the beginning of next time.